The journey towards searching for knowledge begins with a few steps. Grappling with structures, paradigms, ontologies, epistemologies, and methodologies. We begin our journey with research. Battle with zoonoses to ensure public health. Come, witness how our research helps all species, great and small, survive amidst the human chaos. Behold how the pragmatic application of our research would aid the macroeconomic indicators of this country by managing livestock and extension services. Open your eyes, and through the soft rays of light, you will see how new paradigms emerge, boundaries break, structures are questioned, alternative structures are made, multiplicities are promoted, and how the intrusions of the neoliberal market needs are questioned. Walk towards those rays of hope, but tread carefully. See the world around you, but look carefully and celebrate. Celebrate the beauty of life through embracing hybridity. And open doors to an inclusive, broad world through the paradigms of research.
Hello, a very good morning and a warm welcome to the second Undergraduate Research Symposium 2022, organized by the Faculty of Veterinary Medicine and Animal Science, University of Peradeniya. Ladies and gentlemen, this is the second time that the Faculty of Veterinary Medicine and Animal Science is organizing a symposium of this nature for students to present findings of their final year animal production and health research projects. It is important to highlight that it is the Veterinary Medical Education Unit of the faculty taking the challenge of organizing this novel endeavor. I have no doubt that this symposium would be a stepping stone for many future researchers who are yet to change the dimensions of research in the years to come. In order to begin today's proceedings, let us now collectively sing the University Song of Peradeniya. gentlemen, let me now most cordially invite the chairman of the Faculty Research Committee, Professor Ruwini Kalupahana, to welcome all of you joining with us through the virtual platform. Madam, the screen is yours.
Ladies and gentlemen, very good day to all of you. It gives me great pleasure and privilege to welcome you all to the second Undergraduate Research Symposium of the Faculty of Veterinary Medicine and Animal Science, University of Peradeniya. On behalf of the Faculty of Veterinary Medicine and Animal Science, I warmly welcome Professor M.D. Lamawansa, the Vice Chancellor of University of Peradeniya, Professor Terence Madhujit, the Deputy Vice Chancellor of University of Peradeniya, Professor Janaka Ekanayaka, the keynote speaker of the day, and the invited guests and the judges. I also warmly welcome the Dean of the Faculty of Veterinary Medicine and Animal Science, Professor Anil Pushpakumara, heads of the departments, academic and non-academic staff, and the students to the symposium. Now, this is a very important day in the faculty calendar, the day our final year students present their research findings. So conducting a research project is an integral part of the BVSc curriculum. So it gives a very great opportunity for the students to learn how to conduct a research and how to present it to an audience. So our students are waiting to present their findings today. I wish you all the very best to all the presenters, and I hope all of you will find a very fruitful day. Thank you.
Thank you very much, madam. Next, let me most ardently invite the Dean of the Faculty of Veterinary Medicine and Animal Science, Professor Anil Pushpakumara, to address the online audience. Sir, the screen is yours.
Very good morning to all of you. Chief guest, Professor M.D. Lamawansa, University of Peradeniya, Professor Terence Madhujit, Deputy Vice Chancellor, University of Peradeniya, Professor Janaka Ekanayaka, keynote speaker and chairperson of University Research Council, all special invitees, judges, chairpersons, academic staff members of the faculty, presenters, and students of the faculty. It's a pleasure to speak few words at the inaugural session of the Undergraduate Research Symposium of the faculty. Student research projects have become mandatory through the curriculum revision, which came into effect in year 2000. Over the years until 2020, undergraduate research project presentation was not given much prominence, and the first undergraduate research symposium was held with the participation of former Vice Chancellor Professor Upulvi Disanayake in 2020. The last year's undergraduate research symposium could not be held due to COVID pandemic, and this year's symposium was planned to be held physically, but the events unfolded over a couple of weeks' time, compelled us to organize this event online. This year, we adopted a new format for the symposium, and it is very much similar to the format of the scientific sessions of Sri Lanka Veterinary Association. In this format, we have a common session from inauguration to lunchtime, and during post-lunch session, there will be 4 parallel sessions. The whole idea of adapting to this format was to save valuable time of our respected judges and the members and the chairpersons. And of course, going online could cut down most of our expenses. Having recognized the importance of students engaged in research projects, Vice Chancellor has persuaded the University of Peradeniya to allocate 10 million rupees for student research projects across the 9 faculties. This year, Our faculty under the scheme allocated with little over 500,000 rupees, and each student research project will get approximately 8,500 rupees, and the supervisors are supposed to disburse the funds as decided by the faculty research committee sometime back. I have good news for the students of the batch 2016 is that your degree results will be out soon, probably with the release of the project's grades. If not, I am pretty sure the results will be released in July, early July. Please don't be disheartened if you are not obtained the anticipated results. And to have a career in research, your results is not that much important. Getting the first class or second upper, of course, would help you to secure a place for postgraduate studies. And that doesn't mean that you would excel as a researcher. I can give many examples from our profession of how vets with marginal results or grades have excelled as well-known researchers, not only in Sri Lanka, but also in famous universities abroad. Before I wind up, I would like to extend my sincere thanks to Dr. Suranji Vijayakorn and the members of the Veterinary Medical Education Units for their effort to bring this symposium a reality. And my special thanks goes to our new PhD returnees of the faculty who accomplish the difficult task assigned to them by the committee. And finally, I wish good luck for all the presenters. Thank you very much for giving me this opportunity.
Thank you very much, sir. Next, we have something very significant in today's agenda. It is the address by the chief guest. It is a great honor to welcome the Vice Chancellor of the University of Peradeniya, Professor M.D. Lamawansa, to address the online audience. Sir, the screen is all yours.
A very good day to all of you. Professor Anil Pushpakumara, Dean of the Faculty, Professor Janaka Ekanayaka, the keynote speaker today, Deputy Vice Chancellor, Deans of Faculties, academic and non-academic staff of the university, student researchers, the other students, ladies and gentlemen. First of all, let me appreciate your invitation for me to be the chief guest at the symposium. I congratulate the faculty for organizing this conference amidst many difficulties you face. That speaks volumes of their keenness to promote research culture among students. Undergraduates do partake in research, and it is a concept that the university is promoting across all faculties. These research opportunities made available for students who wish to taste research. The goal of such research, even at the student level, is to investigate a subject and gain experience that can further your career. We engage in research when we do not know what we are doing or what we are supposed to do. By creating the knowledge what to do correctly, then we change our practice. It has been said by von Braun, I quote, "Research is what I am doing when I don't know what I am doing," highlighting the statement I made before this. All of us students, supervisors, and institutions benefit from research. It gives students an introduction to a career in research, an opportunity to develop and explore different laboratory techniques, improving research skills, improving your CV, and networking with researchers and the other workers related to research. For supervisors, it is time consuming, but actually it is interesting. Supervisors benefit from improving the productivity, their own productivity and of their units and the departments, enhance teaching and advising skills, and they get an opportunity to brainstorm the problems that they face with the students, whether they are undergraduates or postgraduates. And also, because the students' schedules are so tight, this indirectly compels the supervisors to plan and implement projects carefully with adhering to deadlines. For supervisors, selecting a small project that an undergraduate can be involved in is the key point of success. Sometimes we supervisors may fail to do so. Having several projects on offer helps students to select their preferred area rather than we giving just only one topic for them to engage in research. And also we need to be very clear about our expectations, joint expectations. One of the outcomes of these expectations, or one of the expectations must be to aim at publication rather than oral or poster presentations. Some of us are very happy about. Dear students, researchers, it is to your credit that you have been able to complete a research project. Some of you will be making a presentation today, and that will be remembered by you for the rest of your life. I can still remember during my first research presentation how nervous I was, but rattled off in no quick time because I had prepared. Those days we did not have this kind of PowerPoint presentations, either the slides or transparencies. And also how happy I was to inform one of my very close uncles and a mentor about my maiden research presentation, which I made at one of the surgical conferences. Like me, you, I am sure, will have that experience to cherish from today's event. University has taken several steps to promote research, and especially among students. And the deans and the academic staff know that we have allocated some funding for student research. Continuation of this depends largely on the successful outcome, which the administrators, the heads of the departments, academics, and students too need to take into consideration in implementing the research projects using these funds. Finally, while thanking once again the faculty for giving me this opportunity, I wish you an excellent research conference. Thank you very much once again.
Thank you very much, sir, for those encouraging words. Let us now move to something very important in today's agenda, which is the keynote address. In order to introduce the speaker, let me most warmly invite the chairperson of the Veterinary Medical Education Unit, Dr. Suranji Vijayakon. Madam, the screen is yours.
Thank you, Dr. Chandra. Good morning, everyone. It's my great privilege to introduce our keynote speaker, Professor Janaka Ekanayaka, to the gatherings. Professor Janaka Ekanayaka joined University of Peradeniya as a professor of electrical and electronic engineering from the University of Energy at Cardiff University, UK. Prior to joining the Cardiff University 2008, he has been attached to the University of Peradeniya and was promoted to professor in electrical and electronic engineering in 2003. Professor Ekanayaka is an expert on wind power generation and their connection and modern power system. He co-authored 5 books published by leading publishers. He is a member of the editorial board of IEE, Transaction of Energy Concern, and the Journal of Wind Energy, and he's the editor-in-chief of the 6th IEEE, International Conference on Industrial and Information System. Further, he's a general chair of the 2nd International Conference on Industrial and Information System. He's a council member of the Institute of Engineers of Sri Lanka. Currently, he is working as a director of University Research Council. So without further ado, ladies and gentlemen, I pleasantly welcome our keynote speaker, Professor Janaka Ekanayaka.
Good morning to everybody. The Vice Chancellor, Professor Lamavansa, the Deputy Vice Chancellor, Professor Madhujit, the distinguished invitees, my dear colleagues and students who are presenting papers on this symposium. First of all, let me thank the organizing committee for inviting me to deliver the keynote address for the second undergraduate research symposium of the Faculty of Veterinary Medicine and Animal Science. Let me switch off my video so that you can look at the slides without any disruptions. Now, today I'm going to talk about AI applications in veterinary medicine. Those who do not know the term AI stands for artificial intelligence, and I will give you an introduction to artificial intelligence and the artificial intelligence techniques. And I will briefly discuss why AI now. And finally, I will take few examples to show how AI could be applied in veterinary medicine. Now, when we were young, I could remember there was the TV hit, which says that the IBM computer Deep Blue beat the world chess champion Gary Kaspersky. So this was a big change because on our thinking of machines, and this is probably the historic moment where the machine beat the man. Now, this computer program was developed by the Deep Blue team in IBM software, which you can see the team sitting here. Now, it was mainly based on thousands of computer coded rules. If you can see a few rules given here, if something, then something else, something, and if you have to write, for example, if the prawn is at cell, say 2A, then the white prawn is at cell A, then move the black prawn, black whatever the best move to the whatever the next. All that has to be written in number of codes, if then statements, if then else or else if statements. So those are called the rule-based AI, where we are having certain operational input data. We know that how the chess program is working, and we use a traditional software. Any software can be used, and we translate the human knowledge to these rules. So one can think when in the chess board, when two particular the pieces are in two locations, what should be the next possible move to win the game. So you can see that the humans has to work out these things as they usually do and convert it to set of rules and write it that in traditional software, like if, then, else, safe, and that kind of statements. Then you get the operational output. But more recently, basically the rule-based AI, which is the older version, it's basically attempts to represent the human knowledge into program set of rules. Basically the computers can learn the human thought process and cognitive functions, and but one advantage is, because you have a capability of including the knowledge of many experts, computer can execute this combined knowledge in a fast and in more effective manner to do a function. But On the other hand, we have the second type of AI we call machine learning AI. Now, here the system learns from examples, which we call the training data. Now, it's important that we have adequate data to train our system. So basically, the top row is the same, but you can see that the bottom row, the training data is input to the machine learning training algorithm, which basically go through various, the stages, and it automatically records on his memory what should be done if something happens. So the rules are automatically generated and coded and kept. So here the knowledge is learned by applying an algorithm to a training data set. Those are the mainly two types of AI applications you will see. Now, the first appearance of AI, or the computer machinery and intelligence, was in 1950. In fact, before even I was born. So, but it did not really pick up that during that time. There was few reasons for that, and one of the reasons was why the AI picking now for many applications. If you look at around you, sorry, there are many AI applications. Even your mobile phone is using many AI applications to learn you. So the question is, why we talk about AI now? Why not when it was originally appeared? The main reason is now there are massive data sets. Now, before COVID, I'm sure we had many other pandemics, but we don't have similar amount of data. Now, as I said, if it is a machine learning algorithm, the output of that machine learning algorithm depends on the input data. So the input data should be rich. And today we have data in the form of text, numbers, images, audio. For example, this is a particular research team is developing a data set for this particular disease, which I'm not going to tell anything about it because I don't know. This is, they call it PRRS virus. I'm sure you know more, all about it. And you can see that the data is available in two forms. This is the most important thing for AI application. One is called the temporal data, or the time form of data, how the number of cases changes weekly. So these are weekly percentage averages. The second set of representation of data is the spatial data, or how these cases are distributed in space, a geographical distribution. Once you have both these, you can easily work out how the contact tracing could happen, how the cases can increase, and so many things you can do with AI. The second important thing is, as we know, that our cortex carry the ability to purpose various functions within our memory. One has about 10 to the power 11 neurons, each with about 10 to the 4 weights. Now, this allows, when we wanted to do some functions, these huge number of weights comes into action and do computation in a very short time, so that we can do our any functions within very quick time. So if you look at the number of operations our brain can do, it is 10 to the power 17 operations per second. If one of your normal desktop computer has 1 to 5 into 10 to the 9 operations per second, much less than what our brain can do. The closest computer to brain was developed by Japanese team called K computer, which can do 10 to the 16 operations per second. But to do this, a massive parallelism is required. That means you need so many computers working in parallel to do such a fast job. So that is the second reason why the AI has become a topic today. And when you look at the computing power, the K computer that I just described to you has 1.4 million gigabyte of RAM with 705,024 CPU cores. Remember, we are talking about in our machines called 4 computers, 4 CPU cores. Here it has 705,000 CPU cores. And we talk about 2 gigabyte of memory. Here we are talking about 1.4 million gigabyte of memory. Now, the fastest computer we have, which is at the Computing Engineering Department of Faculty of Engineering, which can do 256 gigabyte of RAM, and it has 32 CPU cores. In fact, for my one of my project funded by Canada, I was trying to order a computer which has a 10 gigabyte of RAM and 6 CPU cores. And this procurement process is delayed partly because of faults on our side and partly because of the country situation. And now we have been trying more than 8-9 months, still the computer has not come to my hand. Now, if you are a researcher working on AI, you can have access to cloud, which allows us to access massive computing resources. For example, the Google Cloud has 1,400 gigabyte of RAM and 224 CPU cores, which you can access. Unfortunately, many countries can access this computer free, but Sri Lankans unfortunately cannot. We need to pay for that. And the fourth, reason why AI is now famous, there are many open source codes. You don't need to really develop your own programs. So for example, if you wanted to do visual identification, the YOLO version 4, it can detect people. So it's a program which was developed by another team and now available for anybody in the world as an open source code. And you can use that to recognize people. Similarly, open post key point extractor, we were using both of these to look at the contact tracing of COVID. We are right now having a project with the Defense Ministry. So basically, these will allow us to look at a particular thing. So what AI can do? It can recognize patterns, facial identification or facial expressions, handwritten or spoken words, or medical images. I'll come back to some of these in a minute. It can generate patterns, generate images or motion sequence. It can recognize anomalies. This is very important. If you look at, for example, certain cells, and if a particular cells are different to other cells, those kind of patterns can be easily recognized from your AI tools. And you can do predictions. For example, we are doing COVID-19 related prediction, which is available in our website, which allows one to tell what's going to happen next, which is important during a pandemic time. Let me take a few examples to elaborate the use of AI in veterinary medicine. Let me start with foot and mouth disease virus, which was, I could remember, when I went to do the PhD in the UK, which was in 1993, No British people were eating beef. They were so afraid of these. And I could remember many cows were slaughtered. And if you wanted to look at how this these particular pathogen spread, we can use many AI models to represent this pathogen spread. They are summarized here. They can be simple mathematical models. I'm sure you must be using regression modeling, ARI, MySci, RSE, IR. These are standard models people use. But there are machine learning approaches which are linear regression, support vector regression, and so on. There are many deep learning approaches. Basically, we are talking about neural networks. There are many layers of networks trying to learn things. So there are many, many different ways of deep learning approaches, and there are also hybrid approaches. Now, for example, in our particular project, the COVID project that we are doing, which is an application of AI to detect, to determine the contact tracing, COVID spreading, and also look at the containment measures. We are developing a simulator using deep learning approaches to see how the COVID can spread, COVID virus can spread in different communities. So we did the massive survey to get the data into our AI system, and we developed our emulator, we call it, which has many stages, which is a very complicated program. I'm not going to go in the stage by stage, but basically we have a simulation stage and the analysis stage. Initially, we initialize the parameters and we setting up the environment, based on the demographic that we collected, and we also say what kind of containment measures having in that particular area, what type of testing has been done, what are the vaccination. Then we also go into the running stage where the people start moving. So we work out how these moving can basically create ways of spreading the virus, and then we can do many testing, and finally we can come up with some the useful outputs, which we have now signed an agreement with the MOU with the Ministry of Health, and trying to feed this, we are going to give this emulator as an open source model to the ministry. Ministry members are also frequently having meetings with us. So we studied the 4 containment policies just to see how the COVID containment can happen. The 4 containment measures are no containment, roster-based containment. That means the people, only set of people comes at a time. The quarantine tested positive patients who are in a quarantine center, and the complete lockdown. And what you are seeing here is the disease propagation, number of total infected cases against the number of days. You can see initially this is just increasing, and we decided to do one of those measures, normal lockdown, quarantine, or roster, at that day 20, and how the containment takes place thereafter. And you can see the blue one is the normal one, with the shadow area shows the uncertainty. The red one is the roster-based scenario. The green one is the quarantine, and the orange one is the total lockdown. And you can see that how the the number of infectious cases increases over the days. Also, this shows the reproduction number, and that also been worked out for 4 cases. Now, that's one example. I'm sure I just showed you for COVID. You can think about many other, as I showed you for the foot and mouth disease, because they are from one cow to another cow. There are I could remember 3 or 4 mechanisms of disease transfer. So you need to model all that in this kind of AI simulator to see how that disease progresses. Then the second example is smart telemedicine. I'm sure this is now happening. So you can have, the external data such as the weather, landscape, and so on. You can also get, if the animals are in a building, the building, ambience, detention, trade, and all that from the farm. And from the animal, the health, production, behavior, and feeding. These can be taken from the wearable sensors on animals and so on. All that data will go into a predictive model based on AI. And those predictive models will tell what will happen to a particular cohort of animals or a particular individual animals, and send alerts to the user or the farmer, so that farmer can take action. So these kind of systems are being developed. They are not new, and that's another application of AI in veterinary medicine. This is another interesting one I found from the internet. Now in AI, there are 2 types of AI techniques, or the machine learning technique. The one is the supervised machine learning techniques, and another one is the unsupervised machine learning. For example, I showed you some visuals of YOLO version 2, and the other one I can't remember the name. Now there we told the AI program to look for people or look for fingers. That is called the supervised machine learning. Here, this particular animal comes, the vet takes a X-ray. He tried to go through any, this particular, the animal had issues of walking. He went through the X-ray, couldn't find anything. So he just gave some antibiotics and sent the animal home. But according to the story, which is, I don't know whether the story is true or not, but according to the story, this particular AI platform managed to locate a hairline fracture, which could not be seen by the 2 doctors. So here the doctor did not tell the AI what to look for or where to look for. Your fracture could be anywhere on his legs. So it's unsupervised. It's automatically look for various anomalies with respect to the thousands of similar X-rays that has been stored on the computer, and look for any anomaly and found a hairline fracture. So this particular software is called Signal PET. It's a patented software platform that uses machine learning and AI to examine and interpret radiographs. Now, as I said, it uses its own database and also the databases which are, available commercially and in open spaces. So you can see that, I'm just giving you a few examples. If you are interested on, getting more insight into machine learning, just Google it. I'm sure you will find many examples. Now, some of the commercially available tools are renal tech, which can, recognize chronic kidney diseases. It not only recognize, it also can tell what is going to happen in one year's time, 1.5 years, all that predictions can be done using this software. I mean, I have not seen this software or used this software. I just giving you the information that is available on the internet. And there are many software to look at to use the machine learning to scan various the things to support diagnostic confidence, streamlined workflows, and engage client with easy to read AI reports. The signal smile is another common pathology. It can detect common pathologies on dental X-rays with AI. And in pre-med, basically they can be used for best cancer treatment decisions for dogs. So, there are plenty available in the market you can use. So again, thank you very much for inviting me to deliver this keynote. I'm sure you got some insight into AI applications, and as the university is now promoting multidisciplinary research, there are AI teams available in engineering faculty, in the Department of Computer Science, in Department of Electrical and Electronic Engineering, and in science faculty, in Department of Computer Science, in engineering, it's the Department of Computer Engineering. And, you have a lot of new novel research that can be started with the use of AI. So I'm looking forward to see more and more AI-based research on the near future. Thank you.
Thank you very much, sir, for that informative address. Well, ladies and gentlemen, we have reached the conclusion of the opening ceremony of the second Undergraduate Research Symposium organized by the Faculty of Veterinary Medicine and Animal Science. In order to propose the vote of thanks, it's a great honor to invite the chairperson of the Veterinary Medical Education Unit, Dr. Suranji Vijaykur. Madam, the screen is all yours.
Thank you, Dr. Chandridu. Ladies and gentlemen, a very good morning to you all. It gives me immense pleasure to deliver the vote of thanks for this event to all the dignitaries assembled here. First of all, I would like to express my gratitude to Vice Chancellor, Professor M.D. Lamavansha, who honored this function with his inspirational thoughts. And also, I would like to thank the Deputy Vice Chancellor, Professor Terence Madhujit, and our keynote speaker, Professor Janaka Ekanayaka, and all the invited guests who have been with us today through online. Dr. Himali Kotalawala, Director General, Department of Animal Production and Health, Dr. Kotalawala, Director, Veterinary Research Institute, Professor Kozala Marambe, Chairperson of Medical Education Unit, Dr. Niranjala De Silva, President, Sri Lanka College of Veterinary Surgeons, Dr. Susanta Malavarachi, President, Sri Lanka Veterinary Association, and Dr. Nimal Jayavira, President, Veterinary Alumni Association of Peradeniya. Thank you very much for joining with us today, Undergraduate Research Symposium 2022. And especially the judges, Professor H.K.I. Pereira, Dr. M.P. Paranagama, Dr. Oswin Pereira, Dr. Gayani Veerasurya, and Dr. Samantha Idamaldeniya. Thank you very much for sparing your valuable time from your busy schedules to grace this event. Thank you very much. Our special thanks goes to Drs. Tushari Gunwardana, Dulari Tilakaratna, Satyana Dishani, Eranga Diseram, and Namalika Karuraratna, who volunteered their service to select 14 research projects from 4 different research subtopics. By taking on this tedious task of going through the 43 research projects which submitted on time, on behalf of the Veterinary Medical Education Unit, I really appreciate your commitment. As you may be aware, Dr. Vijitha Dharmavardhana offered a prize for the best research presentation related to poultry. On behalf of the veterinary faculty, I am so grateful for your generosity. When talking about the virtual delivery of the events, another team that cannot be forgotten, that's my technical team. Thank you for being with me today, our technical team, Dr. Thirinyanupama, Dr. Satyanadishani, Mr. Indrajit Soisa, Mr. Ganganath, Mr. Hashinta, and Ms. Kajini. VMU is highly appreciate your enthusiasm and support rendered toward this more way than one. Preparation of the proceeding is one of the most labor-intensive tasks of these whole exercises. I express my deepest gratitude to the editorial board comprising of 2 editors-in-chief, Drs. Chanaka Rabel, Dr. Sampath Goloku Galapati, Dr. Thirinyanupama, and myself, Dr. Satyanadishani, Dr. Lalanthi De Silva, and Mr. Indrajit Soisa. Thank you very much for being and give your volunteer service in the editorial board. Also, a warm thank goes to all our chairpersons of the different sessions, and thank you very much for accepting our invitation to being as a chairpersons and give your massive and immense support to the success of this event. In addition to the proceedings, an event in this nature involves lots of planning, inviting judges, guests, students, and sending out of numerous emails, etc. So it would not be incorrect if I say that Dr. Lalanthi played a key role in almost every aspect of this exercise. Thank you very much, Dr. Lalanthi, for being with me today with the whole journey of this undergraduate research symposium. An event of this nature can never be organized if we didn't get a support from the top. The Dean, Professor Anil Pushpakumara, fully supported and encouraged the veterinary medical education right from the onset. So on behalf of the Veterinary Medical Education Unit, my deepest gratitude to you, sir. Ladies and gentlemen, as you know, this is the only second undergraduate research symposium of the Faculty of Veterinary Medicine and Animal Science. I wish you to thank our former dean, Dr. Madhur Munasinghe, who was instrumental of initiating this undergraduate research symposium of our faculty. We also had enormous support from our senior assistant registrar, Mr. Ekanayaka. Thank you very much. And also my special thanks goes to Dr. Chandridu Abekon, our comparing person today. So thank you very much, Chandridu, for being with us today. And last but not least, that one of this could never been happen and it not be possible if it wasn't for the excellent student projects mentored by their respective supervisors. My sincere thanks goes to the supervisors and the examiners who are from our own faculty and VRI, Department of Animal Production and Health, and medical faculty, and in several other professional bodies. And all the presenters who are going to present their pre-recorded oral presentations. Thank you very much. Last, I wish all the very best for our presenters today and hope you all have a fascinating and engaging day. Thank you very much and stay safe.
Ladies and gentlemen, to mark the conclusion of the opening ceremony of the second Undergraduate Research Symposium, please rise for the national anthem of the Democratic Socialist Republic of Sri Lanka.
Sri Lanka Mata, Appa Sri Lanka, Namo, 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 Namo Mata, Appa Sri Lanka, Namo, 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 Namo Mata, Sundara Siri Varini, Surati Ati Sogamana Lanka, Janya Ganaya Vikamal Pala Guru Kiri Jaya Bhumi Ramya, Apahata Sapa Siri Sekta Sadhana, Jivana Mata, Pili Ganu Mana Apabhakti Puja, Namo Namo Mata, Appa Sri Lanka, Namo 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 Mata. ඔබමය අප සත්‍යා ඔබ වේ අප ශක්තිය අප හද තුල භක්ති ඔබ අප ආලෝකේ අපගේ අනුප්‍රාණී ඔබ අප ජීවන වේ අප මුක්තිය ඔබ වේ නව ජීවන දෙමිනේ විදින අප පුබුදු කරන් මාතා ඥාන වීර වඩවමින රැගෙන යනු මැන ජය භූමි කරා එක මවකගේ දරු කැළඹෙලිනා යමු යමු වී නොපමා ප්‍රේම වඩා සමතේද දුරනදා නමෝ නමෝ මාතා අප ශ්‍රී ලංකා නමෝ 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 මාතා අප ශ්‍රී ලංකා නමෝ 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 මාතා
Ladies and gentlemen, welcome to the first session of the second Undergraduate Research Symposium organized by the Faculty of Veterinary Medicine and Animal Science, University of Peradeniya. Let me now introduce the two chairpersons of this session. It's an honor to invite Dr. Sampath Galapatti and Dr. Niromi Jayasekara to take over the controls as the chairpersons of the first session. Thank you.
The journey towards searching for knowledge begins with a few steps. Grappling with structures, paradigms, ontologies, epistemologies, and methodologies. We begin our journey with research. Battle with zoonoses to ensure public health. Come, witness how our research helped all species, great and small, survive amidst the human chaos. Behold how the pragmatic application of our research would aid the macroeconomic indicators of this country by managing livestock and extension services. Open your eyes, and through the soft rays of light, you will see how new paradigms emerge, boundaries break, structures are questioned, alternative structures are made, multiplicities are promoted, and how the intrusions of the neoliberal market needs are questioned. Walk towards those rays of hope, but tread carefully. See the world around you, but look carefully and celebrate. Celebrate the beauty of life through embracing hybridity. And open doors to an inclusive, broad world through the paradigms of research.